This video is entitled Arithmetic Operators, Selected Numeric Functions and Aliasing a Column, and goes along with Chapter 8 of the book, Introduction to Database Systems Modeling and Administration. I'm Dr. Reneau from Shawnee State University, and I'll be taking you through this presentation. In our prior video about the SQL select statement, I said that we could use expressions for columns in our select statement so that we could do math and other things. The standard operators that we use in SQL are similar to the standard operators we use in most other computer applications like spreadsheets and such, using a plus for addition, a dash for subtraction, a star for multiplication. Now, that's confusing because star returns all columns if it's all by itself, but if it's used in an expression, it does multiplication. A forward-leaning slash does division, and we're going to talk about that because it doesn't always do what you think it's going to do. And the percent sign calculates the modulus, and we'll talk about that in another slide. The other thing that you get, parentheses, to change the order of operations, and the order of operation follows the standard order of operations that you're used to using in other applications, doing multiplication and division first, and then addition and subtraction second. And you can see that 6 divided by 5, if they're integers, returns the integer because 5 only goes into 6 one complete time. But if either of them are floats or both of them are floats, then the answer is a float. So sometimes when you're dividing integers, it doesn't give you the answer you want because you wanted a float. And in my second column here, you can see that I multiplied one of the integers by 1.0, which converted the integer to a float, and then did the division with the parentheses where they are. So it converted the 5 to a float. Then it did floating point division and returned a floating point answer. Again, just the difference between databases. So many things are the same, but there are those little peculiarities that you got to pay attention to. Here is an example of using arithmetic functions or arithmetic statements to with our pet database from our sample database in the book. Um, Here in the book we have a column that contains the animal's weight in pounds, but we would like the animal's weight in kilograms. Well, we know that to convert a pound to a kilogram, we divide by 2.2. So in our select statement over there, we can see that we have name, weight divided by 2.2, species ID, those are the three columns we'd like to see from the animal table, and we get the results like this. So instead of seeing the weight in pounds, we now have calculated the weight in kilograms. So here I'm doing a simple select without a table to round this decimal number as either 0 places, 1 place, 2 place, or -1 places. And you can see the result of it rounded to 0 decimal places, 1 decimal places, 2 decimal places, or -1 decimal places, rounding it the 135.1 something up to 140 because you're rounding it to the tenths by using a -1 as the number of decimal places in your round function. To make my examples nice and simple, I'm using a select without a from, which you can do. It just does the math in the columns. We could, instead of using constants, used the column name as one of the operators, one of the operands, one of the arguments to the operator, and it would have used those column values. But we can see here how parentheses work to do some simple addition, multiplication, and subtraction. Within our databases, there's a mathematical operator, and I mentioned it on the first slide of operators. It's the modulus operator represented by the percent sign. And what the modulus operator does is it gives us the remainder of long division. So 6 divided by 5 is 1 remainder 1, so the answer would be 1. 7 divided by 5 would be 1 remainder 2, so the answer would be 2. 10 divided by 5 would be 2 remainder 0, so the modulus would be 0. So it returns the remainder of long division. We use this to split numbers into groups. For instance, if we wanted to divide a bunch of customers into 8 groups, we could do a modulus 8 of their randomly assigned customer number, and approximately an eighth of them would have a remainder of 0, were 1, 2, 3, 4, 5, 6, 7. It's also used maybe to split out the number of hours in a day or number of minutes in a day, and lots of other things. When you get used to using it and you think about the modulo as an option when you're doing division, you'll actually find it's really handy. In the SQLite database, you can only round to the decimal side. You cannot round to the negative side like you could in the other two. And there is a shortcut to round of round expression that will round a number to 0 decimal places. You could also say round expression comma 0, and that would round to 0 decimal places. Here you can see the result of an animal weights in kilograms using a column alias and rounding to give a nice, pretty result. There are two other functions that do sort of rounding things. They're the ceiling function and the floor function. And the ceiling function will return the integer that is the next highest number. So it will return the integer larger than the decimal number that you've passed, and floor will return the integer number that is under the that is under the decimal number that you return. So they're kind of like round, but instead of rounding on the half like the round function does, ceiling always gives you the next higher and floor always gives you the next lower integer. You may also want to create the base 10 logarithm, which would be 10 to a certain power. And to do that, there is the log function that will convert a number to the base 10 logarithm. So you can see how that works. The opposite of that would be power 10 comma and the result of the base 10 logarithm. Here's a brief example of calculating the ceiling of a number, like 2.9 ceiling would be 3, but 2.9 floor would be 2. And there's several other floor and ceiling examples with their results there. When we're using a MySQL or MariaDB database, division using the slash operator will always return a decimal number. So if we divide one integer by another, it will still always return a floating point expression. So 2 divided by 4 is going to return 2.0, an approximation of 2. Um, if we wanted to do integer division, we use the div operator, which is an operator that only exists in MySQL and MariaDB that does integer division. For instance, 3 divided by 2 using the slash would give us 1.5, but using the div operator would give us a 1 because 2 only goes into 3 one time completely. In MySQL and MariaDB, you can see an example here of 6 divided by 5 in a whole bunch of different ways. The first one is 6 divided by 5 as integers using slash, 6 divided by 5 using the div operator, giving us only the integer, the number of even times 5 goes into 6. And you can see that if we divide a float by a integer, we always also get a float. This is the way it works in MySQL and Maria, but this is not the way that division works in all databases, and we'll see that in our slides coming up. Here's an example of splitting up people into groups. For instance, maybe our veterinarian wants to do some testing of and send approximately a third of their customers an email, another third a different email, and then a third of them the veterinarian's going to do nothing to kind of A B test some marketing. So, how do we do that? Well, we could easily, because we randomly assign or we sequentially assign the owner ID or owner number by doing owner number mod 3. You can see that owner 1 divided by 3 is 0 remainder 1. Owner number 2 is 2 divided by 3, which is 0 remainder 2. And number 5, I'm not going to read all of them, but 5 divided by 3 would be 1 divided remainder 2, and that's why the modulo is column 2. So we can do our prescription of sending an email or sending another email or doing nothing based upon this column. And the cool thing about that is that number never changes because the customer number never changes. When we have a significant mathematical formula, noticed in the previous examples that the column header name was the mathematical formula. And that gets to be difficult. It gets to be confusing. What does that column really mean? Well, we can use the as clause to alias a column and to give it a temporary special name just for this extracted record set. So in our previous example of getting animals' weights in kilograms, I can say as kg in the SQL statement, in the select statement, and you can see that this column, instead of being called weight divided by 2.2, is now called kg. So we understand better what that column is by using the as clause and aliasing that column. Here's an example of rounding a decimal number to various places in SQLite. And the results would look something like this. If we were using an SQLite server, an SQLite database, or a Microsoft SQL Server database, division works differently. So be very careful when you got to know what kind of database you're using. If we're using the slash operator on integers, the result will be an integer and it'll do an integer division like using the div operator in MySQL. If we use a slash and either are floats, we will then get a floating point division with a decimal answer. Let's see the results of these. When we're doing math, especially division and such, we sometimes get really long decimal answers that really aren't meaningful and we need to round them. The rounding is different based upon the different databases and exactly how rounding is done. So there'll be several slides here on rounding. The first rounding slide I want to talk about, or the first database, is how it's done in MySQL and Microsoft SQL Server. Um, in those two databases, there's a special function called round, and round, you give it um, round, the mathematical expression, comma, and then n would be the number of decimal places you want rounded to. So if you want it to look at like dollars and cents, you would say round expression, comma 2. But the really cool thing is, what if your number needed to be rounded to the nearest 1,000th? You don't care about the individual dollars. You don't care about the cents. You just want it rounded to the nearest thousands place. Well, that's easy because you can use a negative n. Negative n would round it, negative 1 would round it to the 10th, negative 2 would round it to the hundredth place, and negative 3 would round it to the thousandth place, or round those three digits off to be zeros. So that is really cool. The other thing is that if you round an integer, why would you want to do that? Well, what if you wanted to round it up to the nearest thousandth? The same type will be returned. So if you round a float will be returned. Even if you round it to a number without a decimal point. But if you round an integer, it'll round it to an integer. So let's look at an example of rounding in MySQL and Microsoft SQL Server. Here's a statement. Well, it's like the statement we've been working on and adding features to it to show an animal's weight in kilograms, but we want it rounded to one decimal point so that it just looks a lot better and is less confusing and more meaningful to the person who's using that result. This will work in all of the databases because they all do round to decimal places. Some just use negatives and some don't. In some computer systems there might be a special operator like in Python star star or in Excel the caret to perform powers. But in SQL we use a function called the power function that takes the number, comma, and the power to calculate the power of a number. And you can see that here we squared 2, which is 4. If you need to do a square root, remember a square root would be taking something to the half power. So that would be power of 2 comma 0.5 would give us the square root of 2. Two more functions that you may need as you're doing various things are the ln function and exp function. The ln function calculates the natural logarithm of a number. So it calculates what the power is um, if the base number was 2.71828 approximately, or the e is what us mathematicians call it. The exp function raises the base of the natural logarithm e to the number you say. So you can see that the exp of 1 would be 2.718, the base of the natural logarithm. The exponent of 2.89 would be e to the 2.89 power, giving us almost 18. And that the exponent of the logarithm of 10 would be 10 because those are the opposite functions of each other, the exponent and the natural logarithm. And here is a very simple slide just showing the logarithm, the opposite of exponent. I know this was a long video with a lot of stuff, but glad you made it through. Thank you for watching. If you have any questions, please contact me, and please like and subscribe to this video channel. We really appreciate it, and see you in a future presentation.